everyone, my name is Jean. The title of my paper is Increasing the Utilization of Sorghum, Millets and Pseudocereals, Developments in the Science of their Phenolic Phytochemicals and Biofortification. It's a 2014 paper, but it's a review paper. I chose it because it fits with the Africa Day theme. The crops that it talks about are sorghum, which looks like maize, except that the fruiting body is on top. The different types of millets like cow millet, teff millet, fonio. And then the pseudocereals are monocots that actually have a high starch grain, which is similar to the real cereals or the grass cereals. The crops, these crops are good for, they're consumed as a staple food first of all, but they can also be eaten just to improve your diet because they are gluten-free, and they're also high in these phytochemicals which have a lot of human health benefits. So the different classes of phytochemicals are phenolic acids, flavonoids, phenols, tannins, lignans, and there are different subgroups in each one. And the methods used to quantify the phytochemicals are sort of general spectrophotometry. And the graph here shows the relative quantities. This is amaranth, pseudocereal. This is sorghum. These are millets, and the buckwheat has the highest amount, and that's in milligrams per 100 grams. Then moving on to biofortification. The first nutrient is starch, and they found two basic types, a waxy and a normal phenotype. So the normal phenotype has a certain percentage of amylopectin and a variable percentage of amylose, but the waxy one has high amylopectin. And this has been found in sorghum to be controlled by 3 genes which have to be recessive, and also the absence of the granule-bound starch synthase, an enzyme which is involved in amylose synthesis. Then moving on to protein, in general cereals have low protein concentrations, but these small grains have even lower concentrations. So there's a study that resulted in the increase of lysine content by up to 60%, and they used chemical mutagenesis with diethyl sulfate. And then to improve on the protein digestibility of these crops, they used RNA interference to suppress synthesis of these types of storage proteins, the different types of the caffeurins. So the new formation would now be softer and irregular shaped compared to the smooth and spherical shaped one, which improved the accessibility by protease enzymes. Then they also used the NADP thyroredoxin system. They increased its expression, and it disturbs the disulfide bonding and the cross-linking of the caffeurins again, increasing the digestibility of protein. Then provitamin A is another important nutrient, and there are certain cultivars which are native to West Africa in Niger and Nigeria. However, the amount of carotenoids are actually too low to benefit the human diet, hence the need for biofortification. And the methods used are similar to how golden rice was made, and this is targeting enzymes which increase the biosynthesis of beta-carotene in the plant. They also characterized QTLs for yellow endosperm trait, and they found that it's associated with another phytoin synthase which could also improve biosynthesis of provitamin A. Then they also talked about iron and zinc and the presence of tannins and phytate. And phytate was important because it reduces the availability of the natural minerals, iron, zinc, magnesium, and manganese, and calcium also. And the 2 ways that were used to actually reduce the amount of phytate was controlling the expression of that enzyme, MIK, myo-inositol kinase, which is involved in phosphorylating the precursor to phytate formation. And this resulted in a 46% reduction of phytate. Then the other big reduction was as a result of silencing that gene, the multi-drug resistance associated protein transporter gene 5. I don't know what the exact correlation is, but that silencing of that gene reduced phytate content by 80%. In conclusion, the authors say some of these cultivars that have been developed could be ready for commercial agriculture in the near future, so they'll be available for us to buy and eat. And I think the best crop would have a combination of factors, not just protein digestibility, but also the carbohydrate digestibility in one thing, rather than having different cultivars with different benefits. And there are lots of other things that they talked about in the human diet, which I won't go into detail, but they're basically good for you. Thank you.